We are now going to solve triangle and proportion problems. So we're going to start with similar triangles. And we say that two triangles are similar if any two sides are proportional. And so we're going to look at a right triangle, for instance, if that's 90. So if this A and B is the same proportion as C over D, then we say that these are similar triangles. And one of the places this gets used the most is to estimate heights. So suppose that we have a man who casts a 6-foot tall shadow. He's 6 feet tall, and he casts a 2-foot shadow. Near him is a building that its shadow is 40 feet, but we don't know how high it is. So, assuming that these are similar triangles, and we can when we're talking about shadows, we want to set this up as an equation of height over shadow and height over shadow. And so this is height here and shadow here. Now, we can cross multiply, and actually all we need to do is multiply by 40 the way we set this one up. And 40 divided by 2 is 20. 20 times 6 is 120. So we get that x is 120, or that the building is 120 feet tall. And that has the same proportion as the shadow of this man. Another example, not involving similar triangles but proportions as a whole, is the following. According to the American Cancer Society, the incident rate of melanoma of the skin is 20 per 100,000 population in the U.S. There are approximately 62,480 reported cases of melanoma in the United States in 2008. Determine the population of the United States in 2008. So we're going to set this up as a proportion. We have 20 cases over a population of 100,000. And then we had 62,480 cases over X population. We don't know the population. And so here we're going to cross multiply to get 20x equals 62,480, 1, 2, 3, 4, 5. We then divide by 20 to both sides. And so we get x is, the 0 knocks 1 out. 6 divided by 2 is 3, 1, 2, 4 with 5 zeros. Meaning that in 2008, the population was roughly 312,400,000. And so using proportions and this idea of similar triangles, we were able to set up these problems and solve them.